Hello everyone, welcome to today's session. Today we'll talk about Jenkins. Before we go ahead, let's talk about the agenda of today's session. We're going to understand first, why do we need continuous integration, or commonly referred to as CI in the industry? What is continuous integration? We're going to talk about Jenkins as the primary CI tool. We're going to see how to install Jenkins and set up Jenkins in our lab. And then we'll see some example of how to create a Jenkins pipeline. And then finally, a brief summary of what we talked about in the entire session. Meanwhile, guys, don't forget to subscribe to us and hit the bell icon on our YouTube channel. Also, to learn more about DevOps and its tools, technology, and other relevant technologies, take a look at our training page, the link to which is given in the description box below. So guys, let's talk about first, why do we need continuous integration, or referred to as CI? Let's talk of a scenario where we are not using continuous integration. When we work in a team, in a development team, there are multiple developers. All the developers works on different components for a project or for a code. A developer A may be writing a code thinking a scenario, let's say Python 1.0. Developer B may be writing a code scenario 1.2, 1.3, and so on. One of the biggest challenges that we face as an industry is, how do we make sure that all the developers' code gets collaborated and we are having properly release getting deployed? That is the biggest challenge in the industry. Problem of infrequent release is the word that we use for. Now, another challenge that most developers feel is debugging. Whenever you write a code, there are a lot of bugs and issues. A code is often thousands and thousands of lines. If you don't have any proper continuous integration mechanism or a packaging mechanism, you'll see it takes days, even weeks and months to debug your code to make it 100% bug-free. That is a challenge which really makes development process very slow. So how to test the code? Testing used to be a monotonous task. There are teams used to spend months, a life cycle of a quarter to make the code, complete the test code, and make sure it's bug free. What this used to happen is, guys, two things. You were not able to deliver it on time. Business never used to see value coming out of IT. If business see IT is not adding value, IT is not delivering product on time, they will start rethinking and giving a second thought. Do you need to invest so much money on the IT industry or on your IT softwares? These things were hampering big time in the development and release of modern day deployment software cycles. In modern day world, we want to make sure our deployment cycles are robust. We're able to cater to the need of the market and deploy the products as soon as possible. But with this approach, where we're not using CI tools, it used to take 6 months to develop a product, deploy a product, and make it bug-free. Things changed drastically when we started using continuous integration. Using continuous integration, guys, we can deploy codes at the most quickest pace. Amazon, for instance, deploys code every 11.6 seconds. How that is possible? Using the continuous integration mechanism. Using CI, we use some CI tools like Jenkins and all, where we can automate the process like building, packaging, deployment, testing, so that we can do all those things with a click of a button in a matter of seconds. CI process helps us to deploy multiple releases parallelly. I can do in one day thousands and thousands of releases without impacting our environment and making sure these releases are in line with our requirement. The CI tool has an awesome notification mechanism where it notifies instantly of any success or failures happening. So that if I have to debug the code or troubleshoot it, I will know exactly at the pinpoint location where it is failing. You can do multiple notification management mechanisms like an email, an SMS, any ITSM tool, push notifications. All those modern ways of notifications are possible using CI tools like Jenkins. We integrate these CI tools like Jenkins with modern day build and packaging tools like Maven, Ant, Gradle, so that we can automate the common problems which developers spend their half the development lifecycle, like packaging the code, code review, code deployment, unit testing. All those things can be automated and can be done with a click of a button using these CI tools. Now, what is continuous integration? We talked about it helps so much. It helps to save time. It helps to save so much energy. It makes releases so much frequent. It helps us to streamline the process. Now, what actually is continuous integration? If I go traditionally, guys, continuous integration is basically, you can say, a process which helps us to combine or smoothen the automation of the task, like compiling the code, doing a testing, and deploying the code into our life cycles. How does continuous integration work? Developers who works on projects generally commit their code in any versioning tool like Git, GitHub, GitLab, Bitbucket, SVN. Using continuous integration, we pull the code from the version control system tool like Git, for example, and we automate the process like code compiling, code testing, code review, and then we finally deploy the code in a lower lifecycle environment. You can say continuous integration is sort of development practice where developers pull the code from a version control system and make the code deployed in the lower lifecycle environment. The beauty of using these CI tools is we can automate the process in such a way whenever developer makes a new commit or new change in the version control system tool, we create a sort of pipeline, and the pipeline automatically picks the code from the VCS tool and then compile it and then deploy the software. Another good thing about this, there is least human intervention. So once I have set up a pipeline, I no need to worry about running the code again and again or making the changes. Automatically, it happens in a fully automated process. As I mentioned a while back, we can use the process of whenever a new commit happens, or you can run it on a scheduled basis or something. The term CI continuous integration was first time proposed as methodology in 1991 as a part of the extreme programming concept. At that time, it was not adopted so well, but in modern day IT industry, it has become the bread and butter of smoothing up release process or our development process. In modern day world, continuous integration can be seen as the practice of merging all developers' working copy to a mainstream where you can develop and deploy the code multiple times in the same day with as many changes as possible. There is no limit of how many lines of code it can be. It can be tens and thousands of lines of code which can be compiled multiple times throughout the duration. Let's see a case study where we try to see how things change for an organization after it adopted to the CIO continuous integration mode. Here we have picked up an example of Adobe to see how it helped in the development process. Adobe realized at some point of the time that they are not releases very frequently, which is happening their market percentage share. Adobe was not following the continuous integration approach. They were using the native methods of compiling the code, debugging the code, testing the code, because of which they were noticing that it used to take up to 6 months to release updates. Now, 6 months was a long duration, whereas their competitors were releasing update very frequently, which was helping them to capture market share. Adobe decided at some point of the time that we need to change our software development and deployment strategy, and they tried to adopt the continuous integration mechanism. Once they adopted the continuous integration mechanisms, they found that the response time was a lot better and a lot faster. They were able to deploy the updates more frequently with every time a change was made by a developer or new release was being released, and it helps to reduce the response time, and they were 60% more faster. The development teams were getting more effective, and they were able to redeploy releases far more in a better and structured way than what they were doing without using CI. You can see how CI helps industry. Amazon is the best case study. Amazon in modern day scenario deploys code every 11.6 seconds, almost 5 times every minute. This is all possible using continuous integration. Now, what is Jenkins? We talked about what is CI. We talked about why do we need CI, all those things. Let's talk about what is Jenkins and how does Jenkins fit in this particular picture. Jenkins is an open source automation server which helps to automate the process of development relating to testing, deployment, packaging, and others. It is a server-based system that runs on software Apache Tomcat. It supports VCS tools like Git, Bitbucket, and also support build automation tools like Apache, Maven, Ant. And it helps to make and facilitate our continuous integration and continuous delivery process. Jenkins was first released in the year 2011, and it's a completely open source software as part of the MIT license. Jenkins, guys, is a plugin based software. In Jenkins, you have got plugins which basically used to interact with different tools and components. In Jenkins, plugins are primary releases in languages other than Java. Plugins are available to integrate Jenkins with most version control system tools and most databases. Using these plugins, we set up purposes, for example, unit testing. You can do compiling, you can do packaging, you can create some reports, you can do some logging. All those things are possible using plugins in Jenkins. Another important component that we talk about in Jenkins apart from plugin is Jenkins notification, which we also call as mailer. Using mailer, guys, we can do configure email notification for any results. You can configure scenario, for example, you want mail notification when build is successful. All those things can be done using mailer as the Jenkins component. Another important component in Jenkins is the SSH agent. Jenkins also follows a typical master-slave topology. Now, why do we need a master-slave topology in a CI tool like Jenkins? When we work in an organization, we have got multiple teams which you want to build and deploy their own pipelines or deploy their own soft project codes. Teams don't want that their piece of code runs on a server which is owned by some other team. So what we can do is we can set up a master-slave topology where Jenkins may run on server X, but you can connect multiple other servers which will act as a slave. So when you're deploying a code, executing a pipeline, you can run those code on those XYZ servers. That is the beauty of using Jenkins master-slave. Another good thing about Jenkins is Jenkins can be deployed on any operating system. You can run Jenkins on a Windows node, on a Linux node, on a Mac OS. Jenkins can be deployed on any operating system. And similarly, your Jenkins master slave can be of any OS. It is not at all dependent. Both master and slave need to be of the same operating system. Another important core component of Jenkins is called as JavaDoc. This is sort of plugin in Jenkins, which basically is a part of Jenkins core, which helps us to publish results like build action, build directory, what is the expected build output. All those things that we see in Jenkins, they all are happening using JavaDoc. Let's talk about security in Jenkins. Apart from that, Jenkins have other sort of authorization like project-based strategy, metrics-based authorization, which helps to make Jenkins more secure. We'll talk more about this when we talk about Jenkins overall. So as you can see from the diagram, Jenkins is pulling code from some source control system like Git, Bitbucket. Jenkins try to deploy it. In Jenkins, we have got notification management system using Mailer, where if the build is successful, we get a WAR file, a zip file. We can define how we want the build to be created. And if it is failure, send a notification management to a developer that something happened wrongly with a specific code lines and you need to rectify a code. That is the beauty of using Jenkins. So Jenkins, guys, is to the bread and butter in the industry. There are some Jenkins competitor also in the market like GitLab Jenkins and some others. But by default, Jenkins is the to-go tool for the CI in the industry. Let's talk about what is a pipeline. So far we talked about Jenkins. Now let's talk about what is pipeline in Jenkins. Now let's say I want to deploy a code. The code may have certain steps, like first step, I'm building the code. Second step, I'm compiling, then code reviewing, then packaging, then deploying. How do I automate or combine all these steps which can be executed in one go? To deploy all these scenarios, we create a delivery pipeline. Pipeline is nothing, guys. It's a combination of different steps or different tasks that we need to perform in order to deploy our code. Using a pipeline, instead of doing these tasks or code deployment manually, we combine them and deploy them as sort of a one common approach of a delivery pipeline. There are multiple ways on how you can create a pipeline. The two most common ways or common approaches of using a pipeline, as you can see from the scenario, are declarative approach, and the second one that is used in the industry is scripted approach. This particular example you're seeing is an example of a Jenkins pipeline script. Here you're seeing we're first doing a stage called build stage, where we're combining multiple tasks. Like first we are using Java, we're printing something called echo hello pipeline. Then we're using Maven as the build automation tool and trying to deploy a package. And then we are doing a shell script output of what all things are present in the particular directory structure. A typical example of syntax of how to create a pipeline in Jenkins. It's an example of a scripted pipeline. Now let's talk about the two predominant pipelines that are used in the IT industry, scripted and declarative. Let's talk about what is scripted and declarative and how they're different from each other. A scripted pipeline is a traditional Jenkins pipeline approach, and declarative pipeline is the modern day pipeline approach that is used in the industry. In a scripted pipeline, the syntax was very strict and traditional, while in declarative pipeline, we use something called as groovy syntax. When you use a declarative pipeline, you can get the code from any version system tool like Git and all. You create something called as Jenkins file, and you can download Jenkins file from a version control system tool like Git, and that can be used to run your Jenkins code. When you use a scripted pipeline, you define a code something called as node block. But while declarative pipeline, we define a code in pipeline block, as we have seen in the previous example. Now let's talk about what is Jenkins file and how it can be used. Jenkins file, nothing, guys, is like a text file where you define your entire structure and syntax of your Jenkins. You don't need to download the file, and in particular, you can just give the path of your Git repo. If it is then Git credentials, the private repo, and it can pull all the contents from there and just execute your code. It is a modern day deployment mechanism that we use when we work with a Jenkins pipeline. Using Jenkins pipeline, we use certain things which helps us. Let's talk about this. First is code review iteration. When you do a Jenkins pipeline, you can easily review your code. Your code can be reviewed by multiple developers before you execute it. How that works is, in Jenkins file is stored generally in a version control system tool like Git. You can put something called as PR, pull request for a code review. Different members of your team can review the code before you actually pull the Jenkins file and deploy it. You can do an audit trail, or refer to as log it. You can log each and every step output that is being executed as part of your Jenkins file and can see what is happening when the Jenkins file is getting executed. It's sort of like a verbose logging. Then you can find a single place to store all your data or all your outputs. You no need to have developers scattered here and there and writing their own codes for executing a Jenkins pipeline. Whole organization can approach a Jenkins file methodology where code can be stored in a VCS tool, and from there code can be downloaded and can work as single source for your entire pipeline. Let's talk about Jenkins workflow in particular. How does Jenkins workflow work? Jenkins workflow always starts with the version control system, or you can say source code repository. Multiple developers collaborate and they put their code in a source code system like Git. from where Jenkins try to pull the data from that source control system repository system. There is no mandatory or source code need to be Git. It can be Bitbucket, SVN, whatever your organization uses with. Using Jenkins server, we execute tasks like build, deploy, compiling, packaging, code review. All those things happen using Jenkins server where your Jenkins actually installed or is running. Your Jenkins server can be any operating system. It can be Windows machine, a Linux machine, an Ubuntu machine. It can be any OS of today's modern world availability. Using this Jenkins server, we execute our different tasks and scenarios. In Jenkins server only, we use the mail functionality for the feedback mechanism. We notify developers the commit or the code deployment is successful, it is a failure, it has some challenges, what can be done using the feedback mechanism possible using the Jenkins server. Using Jenkins servers, we always first deploy the code on a lower lifecycle environment. That is a recommended standard practice. We first deploy on a QA server, on a testing server, and once the code deployment is successful on the lower lifecycle, then we go ahead and deploy the code on our production server. That is how the entire Jenkins workflow mainly particularly interacts first. Now guys, let's talk about Jenkins installation, how to install Jenkins in our lab. To give this example, we are going to use a CentOS machine as a reference to install and configure Jenkins. Jenkins by default runs on port 8080, the default port for running Jenkins. So please make sure that if you're using any cloud VMs or any VMs in your organization, that the port 8080 firewall settings are open and configured so that it can be accessible. Jenkins is a GUI based tool. 95% Jenkins job is completely GUI based. We hardly log into our server Jenkins got installed or using a CLI command to manage or run Jenkins. It is completely run and managed using GUI, the graphical user interface, which comes when we install Jenkins. Another prerequisite to install Jenkins is Java need to be present in our machine. We need to make sure that Java is installed in our machine. So guys, let's go to our lab and see how to install Jenkins. So guys, as I mentioned, we're going to use a CentOS machine. So let's just double check. It's a CentOS VM. So we have got the CentOS VM where we are running CentOS 7. First thing, let's install Java. Install -y. You can install any version of Java. I'm installing 1.8.0. We can go for any version. So this completes my Java installation. Another good thing about Jenkins here is Jenkins has got detailed page published by Jenkins community where we can see how to use Jenkins installation for different types of operating system. If you go to jenkins.io/downloads, here you can see the installation step provided by Jenkins community to install Jenkins on different operating system. You have got the stable release and the release which is like beta release. You can select which release of Jenkins you want to use. I will go for the stable release, that is Jenkins 2.2.493.TA3. And since I'm going to use CentOS, I will click on the CentOS installation step for Jenkins. Just copy the steps mentioned here, how to install Jenkins, and paste it in your installation server. These are the RPM dependencies that are needed to install Jenkins. So I'm just deploying them on my server so that these dependencies are present before I install Jenkins. And now let's install Jenkins. Yum install -y Jenkins. Once your Jenkins software is installed, let's start the Jenkins service. Service Jenkins start. Let's validate the Jenkins service got started. So now we have got Jenkins up and running. A while back I mentioned Jenkins runs on port 8080. So let's get the public IP address of this machine. So the public IP address of the machine is 35.223.206.46. Let's copy this IP address and try to access Jenkins on port 8080. First thing, when you install Jenkins, Jenkins for securely asks you to verify the Jenkins code. Just go to this path location and copy the code mentioned there on your Jenkins server. So I will go on the Jenkins server, install Jenkins. I will just cat this directory structure and I will copy this Jenkins secret file secret key, which we need to use to install Jenkins. Click on continue. If your key is valid, it will prompt the next page to install plugins. You get two options here. Either you can install the plugins recommended by Jenkins, or you can select your own plugins which you want to install. Here I will select the install suggested plugins. This step may take a minute or so since it will install a couple of plugins which are needed for Jenkins to properly function. So you can see, as like in the screen coming up, different plugins are getting installed in our Jenkins. So once your Jenkins installation is complete, it will ask you to create your first admin user. Okay, so let's give some username. I'll give username as Edureka. Give some password. You can give any password of your choice. So I will give some password here. Give some confirm password. Give the same password you give above. Some name. I will give the name as also Edureka, and some email address. Click on save and continue. So you got the base URL and it's running on port 8080. Click on save and finish. Start using Jenkins. This is how your Jenkins home screen looks like when you configure Jenkins for the first time. Now let's talk about some Jenkins management. On the left side, you see a tab called Manage Jenkins. This is the place where we do the entire administration and management of your Jenkins. You can see you've got plethora of options here like security, configuration, status information, tools and action, Jenkins CLI. Let's talk about all these tools in depth. Let's first talk about configure system. As the name implies, using configure system, you can configure and edit different Jenkins properties or Jenkins configuration settings. So for example, how many parallel tasks you want to execute at time? There's parallel executor. You can give 2, 3, whatever you want. If you want, you can change the port and specify the default admin address. You can create your own Jenkins email address from where your mail notification should go. Any global properties or variables you want to link are linked at this place called Jenkins configuration. Let's talk about something about Jenkins security. If you go to configure global security, here you see how we can configure security in Jenkins. There are multiple authorization modes you can use in Jenkins. In order to use this authorization strategy, you need to use an authentication strategy. The most common and most widely used is LDAP integration, where you basically integrate the organization's LDAP server with your Jenkins database. Once you've done that, you can use different authorization strategies which are used in Jenkins. The most predominant one used in the industry is project-based metrics authorization strategy. Now, what does this project-based metrics authorization strategy mean? Let's say you have created multiple jobs or pipelines in Jenkins. Now, all these jobs or pipelines belong to different teams in the organization. Using project-based metrics authorization strategy, we can restrict that specific job can only be accessed by team members of a specific group. It is not imperative that anyone who has access in Jenkins can run all the jobs or all the pipelines. Using project-based metrics authorization strategy, we can restrict that. Another one that is used is metrics-based security. Here you restrict the overall access of Jenkins. That means a user A can have admin rights, a user B can have read-only rights. What type of read rights you want to give, like agent-based read-only right, the full job rights, full view right, full source code management right, all those things can be done using metrics-based security strategy. Some of the traditional ways which are not being used so frequently in the industry are anyone can do anything. That means anyone who has access to Jenkins is like full admin. Another one that is being not used these days is legacy mode. Legacy mode is something like you have the default admin role where you're granted the full control over system, or otherwise you have the only read access. It's like read or admin in the legacy mode. The third one that was not also being used is logged in user can do anything. Logged in user, anyone can do anything is almost like similar. Here also people who log in can basically do any of the tasks which is being done in Jenkins. So in modern day industry for security, we only used metrics-based strategy and the project-based authorization strategy. These are the two things which are basically used in modern day world for using Jenkins. Now let's talk about how does master-slave architecture works in Jenkins. How can we configure that and how that is possible? Let's go back and let's go there. Let's go again back to manage Jenkins. You see an option called manage nodes and clouds. Let's see how we can set up a master-slave architecture using Jenkins. By default, the server where you install Jenkins is called as the master server, where your Jenkins server is running. On the left-hand side of the screen, you can see a tab called as new node. Using a new node, we can add any nodes belonging to any operating system which can act as a Jenkins slave. There are multiple ways of how we can set up authorization between a master and a slave node. The most common methods of using master-slave nodes are SSH, launch agent by execution of command. This is mainly used when you're using Windows machine as your slave node. For any Linux machine, we generally go by the secure shell as the authorization strategy. We can add as many nodes as you want as a slave node. There is no limitation of how many slave nodes we can have in a Jenkins architecture. Now let's talk about plugins in Jenkins. Plugins, another important component of Jenkins. When you go to manage plugins, you see three options available here. Plugins where you find updates, means you've installed and updates are available. Plugins which are installed in your machine, which are already present. So if you guys remember, when we installed plugins, we selected an option called install recommended plugins. These are some plugins which get installed by default when we select that option. Then you've got a tab called available plugins. Plugins which are available, which we can use for installation. There's a plethora of plugins which is developed and managed by the Jenkins community, which you can use for installing here. So for example, let's say we want to install a plugin to integrate to any cloud environment. You can find plugin for that also. So if you search for example, Azure, you can find you've got so many plugins to integrate with the Azure cloud. Similarly, if you search for AWS cloud, you can see so many plugins to connect with the AWS services. Same way, you can create your own plugins also. We need to create your own plugins, and you can upload the plugins which can be used for you to installation in your own Jenkins installation. Once your plugin installation has been verified and updated, then it can be used by the Jenkins community as a whole. But initially, when you upload any plugin, it is just for you to use on your own machine. Now guys, let's talk about how to create a job with Jenkins. When you work in Jenkins, there are few terms which we use very often. Items, jobs, project, they all are interchangeable words. They all carry the same meaning in terms of Jenkins. How to create a job or item? Just click on the new item, give some name, let's say job 1. For now, select just freestyle project since we are creating a very basic one. Click on OK. Go on the build tab and select how you want to build step. Execute a shell command, a bash command, now integrated, what is your? For example, I want to execute a shell command. And let's say I want to print something, echo hello from Edureka. Simple job. And just click on apply and click on save. Let's try to build this job. In order to build this job, you see the option called build now. Click on build now. See, my job is running right now. See, my job execution got completed and I can see my first job got completed. Let's click on this one button, the first job execution, and click on the console output. Here you can see how the job execution actually happened. My job got successfully completed and I can see a message getting displayed, hello from Edureka. So simple way to see create a first job and to validate job got successfully completed or not. Let's try to create one more job and then we'll try to see how that works out. Let's say I want to print today's date, for example. So let's again say job 2, for example. Again a freestyle project. Again click on OK. Again click on build. This execute shell. And let's say echo hello. And let's say date. And I want to store this output in /temp/Edureka. And let's click on apply. Click on save. And let's click on build now. You see the job output is successful. Let's click on this. Click on console output. You see it successfully printed this and the output got completed. You see all this job that we execute are done in a specific directory structure on the Jenkins server. So if I go on this Jenkins server, for example, and go inside this directory structure and you do ls, you can see that this job got executed in this directory structure job. Similarly, if I go in the temp directory structure and do an ls, you see when we ran this job, we gave the date should be printed in this Edureka file. If I do a cat and this file name, it displaying today's data. Simple example that whatever jobs we execute gets actually executed on the Jenkins server. We just seen the front end in the GUI, what is being done as part of the Jenkins strategy. Now, how do we do a source code management integration in Jenkins? For example, let's say I have got some code in any versioning tool system, let's say like Git or Subversion or Bitbucket, and I download data from there too. Go to the job or create a new job. Let's click on configure. If you go on to source code management, you see an option called Git. Here you can define the GitHub repository path from where you want to download data. Your Git repository, if you're using a private repository, add your Git credentials and from which particular branch you want to download or clone your code. You can even add multiple Git branch from where you want to get the data. That is how this thing works in Jenkins. Another beauty about Jenkins is build triggers. So every time when I build a job, I don't want to go manually and run the job. We can automate this process using some simple tasks like build periodically. You can define a schedule where you want your jobs to be run. This schedule defined in a cron tab basis, like every 5 minutes, every 10 minutes, every hour, once in a day. We define a cron tab entry for that, and accordingly, your jobs will run automatically in that particular schedule manner. If you want to make your life more simpler and want to run the job every time a new commit a developer makes, for that, go with the option of poll SCM. In a poll SCM option, every time a new commit happens made by a developer, at this specific schedule, check for it. If there is no new commit, the job will not build. But if there's a new commit, the poll SCM will trigger that job. That is how we automate the things in Jenkins. When you build a job, you try to get a sort of pipeline. You can create a pipeline on the basis of multiple scenarios. When you say scenarios, what scenario you talk about? For example, let's say I want the next job to be executed only if my build is stable. or unstable or failed, you can specify a scenario and then say which job want to trigger. For example, I want to interlink job 2 and job 1. I can give job 2 interbuild after job 2 build job 1, but only trigger job 1 only when job 2 is stable. So it's like sort of creating a sort of interdependent jobs where only if my previous job execution was stable or successful, it will go to the next job. Otherwise, it will skip the next job. That is how we build a sort of pipeline using Jenkins. In Jenkins, your slave nodes or your master slave hierarchy can be a node in the on-premise machine, or it can be any cloud VM also. So for example, you can have your Jenkins master server deployed on-premise or in your own data center, while your slave machine can be running in an AWS cloud or an Azure cloud or even both. That is how good Jenkins is all about. Jenkins, guys, completely open source automated software where there's no cost of using it or there is no licensing cost linked with it. How do we automate all those stages and deploy them in a one single code as a pipeline? So now we're going to see an example on how to create a pipeline. Before using this pipeline, we have just make sure that Maven is installed and present in our environment. So let's go to our Jenkins setup. We have installed and configured our Jenkins. Again, just click on new items as we did previously, create a new job or something. Give some name. Let's say I give a name as code. Select the option as pipeline. Click on OK. And when you scroll down, you see an approach called pipeline script. Here, basically, you write your script on how you want to deploy your pipeline for your example. Here, in my scenario, you see we have created this scripted pipeline. Here, there are 3 steps, or you can say 3 stages for our code deployment. The first is we're preparing our code. Here, as you can see, we are downloading the code from a Git repo or a Git repository. Here, we've defined the Git repo path where we want our code to be downloaded. You can specify whichever GitHub path you want to use. Next thing you can see, we have defined an environment variable that is build the code that is getting downloaded from the preparation step. We have named as stage build. Here you can see we are running the bin mvn, the default Maven directory, and we're trying to build this particular piece of code here. Once our code gets built, we are trying to combine this code and create an artifact file, a jar file. You can define whatever format of output you want, a jar file, a zip file, a war file, anything can be defined in this approach. Let's click on apply. Let's click on save. And let's see how this pipeline looks like. So click on build now. You can see different stages are happening. The first one is preparation stage. In this stage, the code would have been pulled from the Git repo. Then the build stage, and finally we see a result that something has happened. So let's click on this job and let's click on the console output. You can see the first stage happened, that is pulling the data from the Git repository. It was a public repo, so no code need to be specified. The data got cloned or downloaded from this Git repository. Once the data was downloaded, it then tried to combine it. So it uses different Maven plugin, like the compiler plugin. For test report, the Maven Surefire plugin. It ran some test cases, you see. It ran some 6 test cases where it had no failures in this particular directory structure on your server where you install Jenkins. So if you go inside the directory structure where you install Jenkins and click on ls, you can see the jar file for your code has been done. So using a very simple Jenkins pipeline, we automate the entire process of compiling, packaging, building, unit testing, and I think it took less than a minute for the entire thing to happen, probably some couple of seconds for this entire step level. That is how Jenkins make life so easy. It overall took us 2.785 seconds. And this 2.785 seconds, it pulled the code from VCS, a version control system. It compiled it, it packaged it, it tested it, and now everything looks good. It packaged our code as a jar file. So that is how Jenkins helps us to make our life easier. So now guys, in today's session, just do a quick summary of what we learned about. We learned about what is continuous integration, why do we need continuous integration, what is Jenkins, what is a pipeline, different types of pipeline used in Jenkins. We discussed the entire Jenkins workflow, and we did a hands-on on how to install Jenkins, the different Jenkins components, and we see how to create a pipeline and how the pipeline helps us to solve our modern day development and deployment strategy. So guys, we hope you liked our session. Please don't forget to hit the like button and subscribe to our YouTube channel.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!